Ever get that feeling like you just want to, I don't know, float away? Like gravity's like totally over it.
Huh. Yeah, I think we've all been there.
Right. But what if I told you we all experience weightlessness more often than we realize? And you don't need a rocket ship to do it. No, sir. Today's deep dive, it's all about finding weightlessness in the most unexpected places. We're talking like a plastic bottle, unexpected.
Okay, now you've got my attention. Plastic bottle weightlessness. I'm intrigued. Where are we getting this insight from? Some secret society of DIY astronauts.
Even better, it's from a research article in Physics Education. And get this, the title is Weightlessness in a Bottle. They actually break down, like step by step, how to recreate that floating in space feeling using everyday stuff.
So we're not just talking about mimicking the visual here. We're talking about like replicating the actual physics of a microgravity environment with a bottle.
Exactly. This isn't some, like, camera trickery. They're illustrating a fundamental physics principle, and get this, it's always at play, even if we don't realize it.
Which brings up a point, a clarification, I guess you could say. When we say weightlessness, we're not saying gravity just up and disappears, right?
Yeah.
Like in the movies.
You're totally reading my mind. Because that's the biggest misconception about space, right? It's like in those movies, someone gets blasted out an airlock, boom, they go flying off into the void.
Yeah, makes for good Hollywood drama. But the reality, it's way more, I don't know, it's more nuanced than that. Even the International Space Station, orbiting hundreds of kilometers above Earth, gravity still has a hold of it.
Wait, really? So those astronauts up there, they aren't actually weightless.
They are, but it's what we call apparent weightlessness. Think of it this way. Imagine you're on a roller coaster, right? That feeling you get in your stomach, that plunge on a steep drop.
Oh, yeah.
That's your body briefly experiencing apparent weightlessness.
So you're saying that split second of butterflies, that's not just the thrill, it's like physics. Okay, I am starting to see why this weightlessness in a bottle article grabbed your attention.
Right. It's such a cool way to show that what we think of as weightlessness is actually a state of free fall, where there's no force pushing back on us, even though, and this is important, gravity's still there, it's ever present.
Okay, I'm getting it. But how does this experiment, how does it even work? Are we, like, dropping bottles of water off buildings for this? Because if so, somebody else can do that. Heights. Not my thing.
Nope, no need for heights, no safety helmets or waivers to sign. The article actually describes two versions of the experiment. One is a really cool take on, that classic Apollo 15 moon landing demonstration.
Oh, right, with the hammer and feather?
Yeah.
To show that without air resistance, they fall at the same rate. But this is a bottle, not the moon, so how are they?
They recreate that vacuum environment in a really clever way using a book and some, believe it or not, some toys.
Hold on, a book and toys, that's all it takes to recreate a moon landing experiment.
It's all about the physics. They're showing that principle we were just talking about, apparent weightlessness.
Okay, walk me through it, because I'm lost. They just, dropped the toys in the book?
So the indoor experiment, you drop a toy and a feather onto a book. The book acts as a shield against air resistance. It's like a classroom-friendly moon landing, right? And they even have a diagram in the article Figure 2. Shows you the whole setup.
Okay, that's pretty clever. But that's just showing the concept, right?
Right.
Where does the bottle come in?
That's where we go outside, and that's when things get really cool, in my opinion. We're talking like full-on tossing a container filled with toys, feathers, the whole shebang, and filming it in slow motion.
Okay, I'm picturing this. I'm picturing it, but I'm not seeing the weightlessness. Am I missing something? Help me out here.
Imagine you chuck this bottle up, right? Everything inside, it's all plummeting down at the same speed. Toys, feathers, even the air itself, it's like they freeze, weightless relative to each other.
Wait, so it's not that they're, like, defying gravity, it's that they're all surrendering to it at the same time.
Exactly. It's constant free fall together, so there's no sense of, like, one object pushing against another. They're all just kind of floating.
Whoa. Okay, that's such a weird way to think about it. I mean, we see gravity at work every day, but to imagine it being, like, negated like that inside the bottle is kind of trippy. You know what I mean?
Right. And what's amazing is this simple thing, tossing a bottle, it actually mimics astronaut training. Remember those toy fish they mentioned in the article?
Yeah.
Think of those like astronauts in a neutral buoyancy tank.
Yeah. You've got to be kidding me. We are simulating astronaut training with a bottle of what, toys? This is why I love these deep dives. I thought this was going to be a quick skim of an article, but this is way cooler than I expected.
And we're just getting started. This all comes down to a pretty fundamental law of physics. Newton's second law of motion.
All right. Time to dust off the old physics textbooks. What's EFMA got to do with all of this?
I'm glad you asked, because everything. But before we get into that, let's break down exactly what's happening inside that bottle, moment by moment, because the elegance of this, it's worth appreciating. So picture this. You've tossed that bottle up, right? It reaches that top point, and for a split second, everything inside, it's just hanging there, like frozen.
Okay, yeah, I can see it like that pause at the top of a swing set when you feel, I don't know, lighter, like you could just like float for a second.
Exactly, apparent weightlessness in action. Now watch what happens as the bottle comes down. This is the important part. Everything inside, the feather, the toys, it all starts accelerating down at the same rate because of gravity.
Right, so gravity's pulling on them all the same, no matter if it's, what, a feather or a toy car, which is where Newton's second law comes in, right?
Bingo. Force equals mass times acceleration. EFMA, the classic.
Wow.
And since the acceleration from gravity, that's constant for everything in our little bottle world here.
The mass of each thing, like, doesn't change how fast it falls.
Okay, but what about the force part of that? That's the key to why they look weightless. Think about holding something heavy, right? That feeling of it pushing down on your hand. That's its weight, the force. But inside the bottle, those toys, they aren't pushing on anything. They're all just falling together in sync. So relative to each other, boom, weightless.
Hold on. So they're still experiencing gravity's force, but because they're all falling at the same rate, it's like that force is, what, canceled out?
You got it. Constant free fall, the whole bottle cruising it together. No sense of one thing pushing against another because of gravity. They're just floating.
That is so wild to think about. I mean, we literally see gravity working all the time, but to imagine it, like, being negated this way,
Yeah.
inside a bottle, like, bending the rules of, like, reality, but with, what, a plastic bottle?
That's physics for you. Uncovering these hidden things that are always there, even if we don't see them normally.
It's like that scene in The Matrix, you know, when Neo sees the code, but this is like actual science, not sci-fi.
Exactly. And just like Neo, when you get those laws, you start seeing the whole world differently.
Okay, so big picture time. By getting this apparent weightlessness thing, what are we actually learning about, I don't know, the universe? What's the takeaway? Give it to me straight.
It challenges what we think weightless even means, right? It's not about getting away from gravity completely. We use the space station example, gravity's everywhere. It's more about getting into this constant free fall. Could be a split second on a coaster, could be, orbiting Earth for a while.
So those astronauts training in those big pools, they're really just experiencing a super controlled version of what our bottle of toys. Makes you wonder what other stuff that seems, I don't know, magical is just physics waiting to be figured out.
Now there's a thought.
You know, the thing is, we've all felt this, right? It's not like just astronauts strapped into a rocket or those zero gravity flight people. It's the, like, rush of a roller coaster that jump off a diving board. We've felt apparent weightlessness. We maybe just didn't know to call it that.
And that's what makes this experiment so cool. It takes something kind of abstract, maybe even a little scary for some people, and makes it real, something you can hold.
Right. It makes you think about how much we just, I don't know, don't even notice. Gravity's always there. It's like force. We never think about it. But then you see it almost, I don't know, like turned off in the bottle. It's pretty wild.
Exactly. It's all about perspective. We think weightlessness, we think up there, space. But it's really about how objects and their movement, how that all works together.
So even down here, stuck on Earth with gravity, we can find these little pockets of, like, physics weirdness.
Yeah.
Suddenly want to hit up a theme park, you know?
Maybe after the deep dive, yeah. But next time you do feel that feeling, coaster, whatever, even just like your feet leaving the ground for a sec, you'll know that's some serious science happening.
And it's not some, like, carnival trick. It's the same stuff that's making astronauts float and satellites orbit and all that. Speaking of which, wasn't there something in that article about, like, they calculated gravity at the space station's height? It was still, like, 8.7 meters per second squared or something?
Nailed it. And a lot of folks, they're surprised by that. They figure that far up, gravity's got to be almost gone, right? But it's still about 87% as strong as down here.
Which goes back to the whole thing about apparent weightlessness isn't about escaping gravity. It's that whole always be falling thing, right?
Exactly. It's not no gravity. It's no support. Those astronauts, the station, they're always falling towards Earth, but they're going so fast, they basically fall around it.
Okay, now that one, that's going to take a minute to wrap my head around. Like, they're constantly missing the planet as they fall, which I guess is kind of how I handled dating for a while there. But I digress.
Different deep dive, maybe. But it shows Science, it's about making those weird connections, those aha moments that suddenly make the universe make more sense.
Totally. This whole thing's got me looking at the world differently. So, to our listeners, next time you're tempted to just skim an article, don't. You never know what kind of rabbit hole it'll lead you down. Who knew a plastic bottle could teach us so much about, of all things, gravity? Until next time, folks, keep exploring, keep asking questions, and keep those brains hungry for more.